blockchain developer with router protocol. Also, yeah, so my blockchain journey had started like 2017. I started developing using Solidity and other blockchain apps. Uh, so this is it. Like since then, we have working on router protocol and making it a bit more success, developing more products. So yeah, this is
Mhm.
that's how we are in router.
Okay, how about you, Pranav?
Hey there everyone, this is Pranav, and I'm working as a developer in Interoperability protocol. And I'm very glad for all of you that you're here. And today, really, we are going to be doing a lot of fun activities. We're going to go through a lot of fun demos, and not only just you'll be learning about what is router protocol and how does it solve the problem of interoperability, but in today's session, you will also be learning how to make your own cross-chain NFTs with just a click of a single button. So how cool is it? And they're talking about my journey. So like it started 2 years back. I used to be a Monstack developer, and later I started learning Solidity and all, and uh, came across a lot on Ethereum, and yeah, so that was my journey, and I'm very glad for all of you are here, and yeah, that's good to start.
Okay, I think that sounds very exciting, Pranav, and I do like your mic. You have like the perfect setting, just to share with everyone about how to do this kind of artsy NFTs, and especially cross-chain, right, with Router Protocol. So very glad to have another co-host today with me, like Mike from Sotatech. So he's going to be handling the tricky technical parts. So how are you today, Mike?
Yeah, hi, thanks, Nico, and hello, everyone. My name is Mike Nguyen, and from my background, I have a 6 years experience working on the blockchain industry at the Sovatech. We are a leading blockchain development company in Vietnam, and I also be a member of the IBC stations, and will be the co-technical host today with Nico. So yeah, thanks everyone.
Okay, so I think we're slowly starting the session. So more people might be joining us later, but I think, well, we would kickstart the session soon with some fundamentals about router and followed by some exciting demo with the team on how to actually build, cross-chain NFTs specifically with router protocol. So my name is Nicole. I'm from APAC DAO. Very glad to be with you today. And I think in the upcoming series, the sessions. So we are a Web3 community with members coming from 10 different countries, and we're having 800 projects and 2,000 members in our community now. So we do education, events, business matching, and also working on this ABC station to specifically support the builders. So now, without further ado, I would hand over to the Router Protocol team to kickstart the session. You can also share your slides from now on. Over to you.
Yeah, sure. So is my screen visible?
Yes.
So yeah, let's give it a start. So let's talk about the agenda for today's session. So first of all, we'll be looking into a brief about router protocol, what router protocol actually is, and what is the problem that router protocol is trying to solve. And after that, we'll be having a demo of the gamified testnet of router protocol, that is Mandara. And it's really awesome. You are really going to love it. And apart from that, we will also be learning some of the resources and tools for builders which can empower your blockchain projects. And we will also be learning how to make our own cross-chain NFT. So yeah, this is our agenda for today. Let's start. So talking about router protocol, there is a term. Some people might be knowing what interoperability is, but for the people who don't know, let me explain. So interoperability is, in very simple words, a lot of blockchains are there in the world today, and like a lot of new blockchains are coming into the market, and like right now also we have a lot of blockchains in the world. So we want two blockchains to communicate with each other. So this communication between different blockchains with each other is basically known as interoperability. So what is interoperability? In simple word, interoperability means communication between different blockchains. Now, why? Now the thing is, like, it's not very easy to establish this interoperability between different blockchains. Now the question comes: why do we actually want to solve this problem? Why do we want two blockchains to communicate with each other? So to understand that, we need to understand a concept called scalability trilemma. So scalability trilemma is simply we have three properties: decentralization, security, and scalability. So any blockchain that come into the market, if we try to make that blockchain more scalable, then we have to compromise with the decentralization and security. So if we try to increase any of the three factors, we have to compromise with the other two factors. I'm not saying like making a blockchain scalable will ruin the decentralization and security. I'm saying if we want to increase the scalability, the amount of decentralization and the amount of security we get, we have to compromise with it a little bit. So this is the problem in today's world. That is, any chain that comes into the market is not perfect. If it's scalable, it's not that decentralized and secure. If it's super decentralized, it's not that scalable. So to solve this problem, we need to go cross-chain. To solve this problem, we need interoperability. Now, for example, let me give an example of social media application, social media DApp. So for posting our post, for making a post, we don't want the users to pay a huge amount of gas fees. That's where we need a blockchain that is more scalable. But for storing the post, after we have made the post, for storing a post, for storing the images or whatever, we need a blockchain that is more decentralized. So here you can say a DApp is using properties of two blockchains. One is scalability and one is decentralization. Now, this is not possible in today's world if we don't go cross-chain, if we don't establish interoperability. So here, this is where interoperability exactly comes. To make a DApp which can use features of multiple blockchains together is the basic use of interoperability. Like, let's say you make a post, you make a post on a chain that is more scalable, so that user need not pay that much amount of gas fees, but the post gets stored on the blockchain that is more secure, that is more decentralized. So this is where interoperability plays a major role. So this is like one of the use cases, but major use case. So in simple words, this is why we want to establish interoperability between different blockchains. So I guess you got the concept till now, right? So yeah. So now let's talk about what router protocol does. So router protocol is a layer 1 blockchain which aims to establish the interoperability. So our vision is to create an ecosystem in which we can establish interoperability between nearly every chains that exists in the world today and will be coming in the world today. So this is the vision of router protocol. So specifically talking about router protocol, it's a cross-chain solution with the mission to foster complete interoperability in the blockchain space. So this is the goal. And talking about why interoperability is needed, I already explained you guys. And if you have any doubts, you can just unmute yourself and ask. And yeah, so this is the mission of router protocol. So let's talk about what is router protocol actually. So router protocol is a layer 1 blockchain which is built using Cosmos SDK. So Cosmos is an ecosystem which basically provides an SDK for the developers to build their own blockchain out of it. So router is a layer 1 blockchain which is built out of Cosmos SDK. And since it is a result of Cosmos SDK, it also follows Tendermint consensus engine. So yeah, this is a brief about router protocol. And you can read this slide if you want to know in depth, since we don't have that much amount of time. So that's why I'm quickly going to the next slide. Yeah. Now let's talk about router protocols gamified incentivized testnet, which is called Vendor. So this is like one of the coolest things out there. So without giving much theory, let's go into the demo of this part. So you can visit this website, and the URL is given over here, https testnet.routerprotocol.com. So I would request all of you guys to just open this URL. Can you get a yes in the chat section if you opened it?
Okay, maybe you just give everyone a bit more time. Yeah. So everyone, please check the chat box. We are having a link.
Can you share as well in the chat section?
Yes, done.
Yeah. She's done. Yeah. We're waiting for everyone to open this a little bit so we can mint the character, the NFTs, like from the community. We just give it maybe 30 seconds. I have opened this too.
Guys, just drop a yes in the chat section if you're done with it.
Okay. Very
Guys,
interesting.
you literally feel like playing a retro game while I give a demo of this. So it's really going to be very interesting. So just open this URL. Okay, I guess everyone has browsed this URL, I guess. Okay, let's go to the demo part. So there's a link in the chat section which you need to open. So let me share this tab. Guys, can you share? Can you see my screen?
Yes.
So this is our gamified incentivized testnet, which is called Mandela. And here you can create your own character. You just need to come over here and click on this button. Now you need to click on create character. Here you can choose your character. So I'm going to choose Dijin. So let me choose this. Here you can choose your gender. So I'm choosing male over here. And here you can choose the skin color as well. So I'm going to let it be this color only. Here you can choose the hairs that you want your character to have. So let me make him wear this mask. And then you can also choose the outfit of your character from here. So let me choose this outfit. And after you have choose the attributes, you can choose the skills, goals, and all these things. And after you have done with your selections, you just need to come over here and click on next. Here you can do the adjustments accordingly. And after you have done with all these stuffs, you just need to click on next over here. Similarly, you can do your adjustments. Whatever you want, you can select yes or no. And then you need to click on next again. So it's saying connect your MetaMask wallet. So if you don't have this MetaMask wallet, you need to install this MetaMask wallet. You can just search on Google, like install MetaMask, and corresponding to your browser, you can download the MetaMask wallet. So I already have this wallet, which comes with the symbol of a fox. So I'm just going to click on this understood. And here you need to give your name. So I'm giving my name over here. And here you can give your email address. So let me give my email address. So after you've done with these stuff, you need to click on Mint. So as you can see, my MetaMask wallet has been popped up. And let me confirm this transaction. Let me sign in. Yeah. So as you can see, the NFT is getting minted. Yeah. So congrats. We are on the level 1 right now, and we can move this character. We can collect the coins, and we can do a lot of cool stuff with this guy. So it's basically like a retro feeling in which I can move the character, I can collect the tokens, I can collect the coins. So yeah, this is our gamified incentivized testnet, which you can just come, enjoy, play, and add this network to your MetaMask wallet. Can you see my screen?
Yes.
So this was about our gamified incentivized testnet, which is called Vendera. Now let's go forward. Let's understand some of the resources and tools for builders. So this is our platform, which is called Text Exchange, and it's a D app, and it basically leverages the stateful part of router protocol. That is, we call that as middleware, and it's basically a token swapping platform, and it works around various testnets, and it basically integrates a kind of background text in which like the liquidity pairs are there, and for all the testnet tokens that exist, and you can check out this D app by browsing this URL. So I'm not getting into the depth of this this D app because I have something more cooler to show you guys. It's built using router protocol. This is another D app which is called Ping Pong. So it basically is used to send a message from the source chain to the destination chain. So ping means sending a message from the source chain to the destination chain, and pong means receiving an acknowledgement back on the source chain that the message has been successfully sent to the destination chain. So yeah, so what ping means is sending a message to the destination chain from the source chain, and pong means receiving an acknowledgement back to the source chain. So this is our ping pong D app, and you can also try out this D app by clicking on this URL. Salini, you can just give out this URL in the chat section so that you can try it out.
I've shared it there.
So this is our another tool, which is called Sandbox. So we will actually be having a demo of this tool, and really you are really going to be enjoying it because now comes the time when we are going to make our own cross-chain NFT, our own cross-chain ERC721 token. So let's get started with it. We just need to click on this URL to open this app. So Luni, you can share this URL as well.
Yes, share.
Okay. So can you see my screen?
Yes.
Yeah. So
Yeah.
this is a sand. Sorry. Yeah. So this is a tool called Sandbox, which basically automates most of the stuff. Like in order to create a cross-chain app, what a person need to do is a person first of all need to have a MetaMask wallet. Then a person need to have a wallet address in that account in that wallet, and then a person also needs to have funds on that particular account. And then a person needs to deploy the smart contracts in the source chain, destination chain, like a lot of hassles there, right? So what this sandbox does is it automates all the process. Like a user just need to come on the sandbox, and with just a click of a single button, a person can create cross-chain dApps. How cool is it? With just a click of single button. No hassle of like having a MetaMask wallet or having account, having funds on that, or deploying the contract. Everything will be taken care of by this tool called Sandbox. So let's understand how to use this Sandbox tool in order to create cross-chain dApps. So in this first column, you need to enter your username. So let me enter. And in the chains column, you need to select your source chain and your destination chain. We have more chains as well, but right now we are just operating with the 2 chains because like internal work is going on with the other chains. So you can select the source chain as well as your destination chain, which in our case is Mantle testnet, Matic testnet, which is our source chain, and Mantle testnet, which is our destination chain. In the environment, let it be testnet itself because we are operating it on the router testnet. And here comes the cool part, contracts. So here we have options to select 4 different cross-chain contracts, 4 cross-chain dApps. First is ping pong. So ping pong, as I've already told, it's a dApp which is used for sending a message to the destination chain from the source chain and receiving an acknowledgement back on the source chain. So this is the ping pong dApp. Whatever dApp we want to create, we can choose it from here. Next we have cross-chain ERC20, which is basically a cross-chain cryptocurrency. So using router protocol, we can create our own cross-chain cryptocurrencies. We can create our own cross-chain NFTs with just a click of a single button using this Sandbox tool. So this is cross-chain cryptocurrency, ERC20. And this is cross-chain ERC1155, which is basically a cross-chain semi-fungible token, which is yet another type for NFTs, or you can call it semi-fungible token, basically. And this is cross-chain ERC721, which is basically a cross-chain NFT. So in this demo, we'll be building our own cross-chain NFT. So let me select this cross-chain ERC721. Okay. Now you can see we have 2 columns over here. First, we have the Solidity section. Next, we have JavaScript section. So based upon whatever contract we have selected over here, it is showing us the corresponding Solidity code. This code we can directly copy and paste it in our desired IDs like Remix, or if you want to use Hardhead platform. So it's the code corresponding to this, to the contract that we have selected. If I change the contract, this code will be changed accordingly. So this is the Solidity code for it. And next we have the JavaScript code. So this can be used to build front-end part of our dApp. So yeah, this is about these 2 code sections. The next thing that we are going to do is simply click on this execute button. So by just clicking on this execute button, you can see our wallet address is being created. Let's wait for some time. You can see our wallet has been created, and this is our address. And this is a private key which we can download by clicking here. In the left side, you can see the transactions. So you can see the native testnet tokens have been sent to this wallet address. As you can see, like Matic testnet tokens have been sent to this wallet address, as well as Mantle testnet tokens have been sent to this wallet address. You can also add this account to your wallet by simply downloading this private key and importing it in your wallet. So let's wait till the contracts get deployed. So as you can see, the contracts are deployed. I guess there is a client-side error, which is an error on my browser. One second. Guys, are you facing the same error? I guess you might not be facing the same error. It's because of my browser. Anyone facing the same error? I guess you will be able to easily mint your NFT. you are not going to face this error. Anyone facing this error? It's because of the browser. There's some problem at the client side. I guess you'll be able to mint your cross-chain NFTs. It's a problem specific to my browser only. Guys, can anyone confirm? Like, are you able to mint your cross-chain NFT? Saluni, can you try once? I guess you'll be able to mint your cross-chain NFT.
Yes, I'm trying. I'm trying. Give me a second.
For me, it's working.
Okay. So it's a problem like specific to my side. You'll be able to mint your cross-chain NFT. So this was our tool called Sandbox, and which basically helps in automating most of the stuffs. With just a click of a single button, we can create our own cross-chain smart contracts. Now let's take some of the doubts. Can I ask a question? Between factors like speed, security, compatibility, and scalability, do you prioritize these factors? If you have to sacrifice some of the factors, more the better. What is your choice? Okay. So determining the better prioritization of factors like speed, security, compatibility, scalability, it's basically very subjective, and it depends on specific requirements and goals of a particular blockchain project. Like there is no universal answer to as which factor should be prioritized more, as it varies based on the use case, and yeah, it basically varies based upon the use cases. So each factor has its own significance, and the ideal prioritization depends on the use case. So you got the answer, right?
Yeah, I understand the questions from the audience because they are all the significant factors that we need to consider. All the chains need to satisfy those factors somehow, but they are asking like what is the what do they prioritize them in the mind of Rota protocol? What is the best the, factor that you're focused on? Like security is better than others, or somehow?
So that is exactly where router protocol comes in. Like it basically tries to solve the scalability trilemma, in which we need not compromise like one of the factors for another factor. Like we don't have to trade it for other factors. So this is exactly where router protocol comes in. So as I gave an example of social media application, social media app, in which an app can, in which while making the post, you can use a chain that is scalable while making the post, like while making the transaction. And after the transaction has been made, the post gets stored on to a different blockchain that is more secure and decentralized rather than being more scalable. So like it basically depends on the use cases, and this is exactly where router protocol comes in to so that we need not trade off any of the factors for another.
Yeah, I see. So we don't want to do any trade-off of these factors. We want to have them all, right?
Sorry, did you say anything?
I mean, I got your idea. So
okay.
yeah.
Another question. I found that I can write EVM DApp on router protocol using Crosstalk. How well is the platform compatible with EVM? Is it fully compatible? Okay. So see, let me tell. See, router protocol. See, router protocol is what? Router is nothing but a blockchain, a layer 1 blockchain, which is built using Cosmos SDK, right? So whatever contracts we are deploying on router chain, that are known as middleware contracts. So these contracts have to be written in a COSM-WASM framework, which is basically a framework in Rust to deploy the middleware contracts. Now, if we come to the crosstalk library, so crosstalk library is a library which basically helps two smart contracts to communicate with each other. Like the smart contract, you can say one smart contract is present on the source chain, and the other smart contract is present on the destination chain to basically have them communicate with each other. We have crosstalk library. So while there is something called gateway contracts, which are pre-deployed on the chains on which the router can be integrated to. Let's say, let's take an example of Polygon and Avalanche. So the gateway contracts are contracts which are deployed, which are pre-deployed by the router team itself on Polygon as well as Avalanche. Now the thing is, in order to create a cross-chain smart contract using crosstalk library, a person needs to deploy the source contract on the source chain. Let's say in our case, the source chain is Polygon and the destination chain is Avalanche. So a person needs to deploy the smart contract on Polygon as well as the same smart contract on the destination chain, that is Avalanche. Now, these contracts, since these blockchains are EVM compatible, so the smart contracts has to be written in Solidity or whatever language supports EVM compatibility. Let's say, for example, Solidity or Viper. These smart contracts can be written in these languages and deployed on the respective blockchains. So what I do is I deploy the source contract on Polygon, and the same contract I deploy on the destination chain, that is Avalanche. Now, the gateway contracts are pre-deployed on Polygon as well as Avalanche. Now, these two smart contracts, that is the source contract that we deployed on Polygon and the destination smart contract that we deployed on Avalanche, can communicate with each other via these gateway contracts. Since these gateway contracts can communicate with each other via router chain, so we can say indirectly, the smart contract present on the source chain can communicate with the smart contract present on the destination chain. How? Because these gateway contracts can communicate with the corresponding smart contracts on that particular chain. Let's say the gateway contract deployed on Polygon can communicate with the smart contract deployed on Polygon, as well as the gateway contract deployed on Avalanche can communicate with the smart contract deployed on Avalanche. Now the thing is, these gateway contracts can communicate with each other via router chain. So router chain is like an intermediary chain between the source chain and the destination chain. So this is how the whole architecture works. So the source contract has to call some of the functions of the gateway contract in order to send a data from the source chain to the destination chain. And like when the data has received on the destination chain, then we need to perform some operations there. So in order to perform some operations, again, the contract on the destination chain has to call some of the functions which are needed to perform an operation when the data is received on the destination chain. So these functions are basically iSend function and iReceive function respectively. So the contract, you asked about EVM compatibility. So the contract, the smart contract that we are writing can be written in languages like Solidity, because after all, the chain that we are using is EVM compatible. So obviously, the smart contracts we can deploy on the respective chains and then call some of the functions. And also, like, we need to import the crosstalk library, the interfaces of it, and we need to implement those functions. And by calling some of the functions of the gateway contracts, by the contracts, we can actually send the data from the source chain to the destination chain, and also perform some operations on receiving the data on the destination chain.
I see. So in your example, the source contract and the destination contracts is the same one, but they can be a different one, right?
So yeah, it can be different one as well. So I just gave an example of let's say cross-chain NFT. So the same contract is there on the same NFT contract is there on the source chain, and the same contract is there on the destination chain. The same NFT contract with the NFT logic in it, and some import statements, which basically are used to like import the interfaces, and then we can implement the functions of crosstalk library. So I was giving an example of cross chain NFT. So the thing is, from the source chain, in order to send the NFT from the source chain to the destination chain, we need to burn that NFT on the source chain and then mint that NFT on the destination chain. So this is what it is meant by transferring the NFT from the source chain to the destination chain. Now, after burning the NFT on the source chain, we need to send the metadata, like the URI and all, and the ID of the NFT to the destination chain, like some of the data which can be used in order to reconstruct, in order to remint that NFT on the destination chain. We want that data to be transferred on the destination chain. So this transfer of data can be done with the help of the crosstalk library.
I see. So it's not really it's like a communication tool between contract from one chain to another chain, right?
Exactly.
We transfer the message here.
Exactly. So like a smart contract deployed on chain A can communicate with the smart contract deployed on chain B with the help of this crosstalk library. It's basically you can say a stateless protocol in which the data is sent directly. So this is what crosstalk library is. We have another framework of router protocol, that is omni-chain framework, which is basically a stateful framework, in which we need to deploy smart contract on the router chain itself, which is called middleware contract. And when the data is sent from the source chain to the destination chain, it has to go through this middleware contract. And there in the middleware contract, like we can write some logic to operate on the data, perform some computations and all, and then transfer it to the destination. So this is another framework which is called omni-chain framework of router protocol. So currently we are having two frameworks: crosstalk library for just stateless protocols, stateless bridging, like just sending the data to the destination chain, and omni-chain framework, like you can say a framework with a middleware contract in between, like sending the data to the router chain, a middleware contract, performing some computations and operations, and then sending it to the destination chain.
I see. Interesting. So we have omni-chain is a middleware contract, right? And you just mentioned that we call it is, if I'm not wrong, is stateful. Is stateful, right? So it means that we have state storing in the router protocol.
Sorry.
I saw that you called as omni-chain protocol.
Yeah. Let's say we want to build an application for cross-chain swaps. So on the middleware contract on the router chain that is deployed on the router chain, we can write logic for it, and then when the data comes here, we can perform that logic for cross-chain swaps, and then we can swap out to the destination chain.
You just call it is stateful, right?
Yeah, stateful. So stateful means it is not directly going to the destination chain. It is first going to the middleware contracts, like some operations and computationals is performed over here, or some data might be stored over here, and then it is sent to the destination chain. So this is the meaning of omni-chain framework.
So the middleware contract is not just only the logics, but also can store some states, store some data, right?
Yeah, it can be stored on the middleware contract.
Okay, I see. So
and that contract is since the router chain is a Cosmos SDK, is built out of Cosmos SDK. So we need Cosmos framework in order to deploy that middleware contract. But for the source contract and the destination contract, since if we consider any event compatible chain, so that can be written in languages like Solidity to deploy.
Okay, so middleware contract must be closing version, right?
Yeah.
Okay, I see. The tech chains, link you just share in the slide is the middleware contract.
Sorry.
The tech chains swap. Oh, okay.
Yeah, it's based upon the middleware contract.
Is it open source?
Sorry.
Is it open source? Can we read the source code in GitHub as like a reference?
Yeah, I guess it's open source. Shashvat, sir, like
yeah. Yes. So currently we have not opened the code, but yeah. So I'll tell you a bit structure like how exchange works. So consider, let's say you have Ether on Gorley testnet. Okay, you want
Mhm.
Matic on Mumbai testnet. Okay, so we have this AMM layer on top of our middleware. Okay, where the price defines like how for how many ether you will get Matic. Okay, so for source and destination chain contract, right? Like a contract that is on uh, Gorley and a contract that is on Mumbai side. These two are open source. For the middleware, we have not open source it yet, but definitely like in some days we will open it. So yes, but by looking into those code, you can easily understand. There are other examples that are open source for the middleware, so that you can definitely check.
I see. So it is the roadmap already, right?
Yeah.
Okay, I see. Thank you for the information. So I also saw the questions in your community chat box that actually seems so similar to our the question I want to ask. It is get back a bit from away a bit from the technical details. It is the question about the motivations to start the projects because I understand that's the pain point that you are trying to resolve, but it is for it is 3 years already from the day you start the project and there's so many things changed. A lot of technologies come that's entire change the industry like a ZK rollup. Previously is mostly is optimistic rollup, right? So is it change anything?
Yes, so as I said, so we have started this project in early 2020 when DeFi summer was in peak. So at that time, there were lots of new ecosystems are coming with lots of very different tech, and there are lots of new blockchains are spawning with lots of new dApps on it, which is calling lots of developers and lots of users on the dApps, right? So these silos are started building over one chain. We have seen like in Ethereum, when there's lots of attraction. We have seen at the time of DeFi summer, like people are paying crazy amount for gas, right? Similar thing you can do it on Matic, right? In just like under $1, right? So this was the thing, and then started booming off other chains also. But the problem was how can we move our funds from chain A to chain B, right? And using this problem, we have started router protocol, where initially we were focusing on just transferring of this asset, and then time passes, we have come up with a cross-chain swaps, where you can have any asset on chain A, you can get any asset on chain B. So this was also our second generation. Now that currently we are somewhere we are creating a Cosmos-based chain which can interact with other chains. Okay, the stateful bridges, right? So by having lots of these tags like ZK rollup or maybe optimistic rollup or by having lots of cryptography proving mechanisms, like line models, right? So there are lots of things are coming. So this gives us more better directions and give us a vision where can we grow, or maybe how can we design our things where people that can use these technology over top of router protocol so that they can create a second layer of security for them, right? Because like if we say tomorrow there will be new tech, a new piece of tech will come, right? And again there will be whole revamping of things, right? So better we focus on more modularity of things and how can we provide it more better for the dApp experience. So That's how we come up with additional security module where and dApp itself can create their own security model, because like we have seen in past there are lots of hacks on bridges, right? So there's always a security concern for all the dApps. So here we can provide POS security, proof of stake security over the chain. But if a dApp wants to add up security using ZK rollup, or maybe have some light client verification system, right? They can create their own. So by using POS consensus and their consensus, by clubbing of both consensus, we can get the result. Okay, so this is some additional layer of security. That's why we call it additional security module. So this is how we are seeing new pieces like CK and all, like by creating module for that and use it using router protocol. So currently we are creating those infrastructure.
Mhm. I see, I see. So, okay, I understand that the pain point that's still there. The pain point a few years ago we trying to resolve is still there. Just we have more directions to resolve that issue now, and currently we are trying to apply better security sections layer over this the base one.
Yes,
Okay.
yes. Mm.
Mm. Okay, in terms of security, we are actually we have a bridge. We are a bridge, right? And bridges are always the target of the attackers. So we have a lot of example like a Nova, the Ronin, uh, like a
Mm.
Wormhole or Harmony. So what do you like think about us, and how confident you are about your security to like address that matter?
Mm. So, yeah, as I said, like bridges are always attack vectors for the uh, hackers. So I
Mhm.
think whole DeFi, if you see whole DeFi as in general, uh, smart contracts, if like whoever has written, if that has some bug or if that is not correctly audited, right? So those are prone to hack. It's not like only bridges are getting hacked. It's like every DeFi protocol who has some vulnerability, right? Those are getting hacked. So for the bridges, even let's say having bridges are also consist of smart contracts. Okay, so even let's say if you build some smart contract which has some security flaw, those are more prone to hack, right? So better to have foolproof like system where you can create your the smart contract and have some operations like multiple audits or community audits, something like that, right? So you can stop like occurring of this errors of this bugs. But with uh, with bridges, there are something more also, like there are validators who are running, or maybe some relays are running.
Mhm.
So security for their keys also important, because if you see like few of the hacks that were happened before, right? Most of them, not most, like few of them are because of leak of their keys, right? Or poor management of their keys, or maybe social engineering, right? So because of
Mhm.
that, we have seen past few hacks, and some of those are because of contract bugs or maybe some calculation errors, right? If let's say if a mother chain has logged 100 ETH, there should be 100 ETH given on a destination side. But let's say due to some bug, if someone can manipulate this one-to-one ratio, right, then there will be chances for the hacks. So yeah, so what I was saying, for the router, right? So router, we have some processes by which we can ensure that we are very less to this attack vectors. We try to reduce as much as possible. So we first create smart contract, then there will be other internal developers who will look into the smart contracts and check for the errors if we got any. Then we will go to other auditors, external auditors, multiple auditing layers like we do on first level, then second level, and then in the end we will public our smart contract to the community before going live, so that community also take a look at the smart contracts and check like if there is any error or not. Okay, based on that we come to this point like now we are secure, but also as I said, like security is something which is very subjective. Like recently we have seen like attacks like Viper, right? So there are few of the controls that are not in our hand, and that can harm a project way way strong. So it's like uh, in router we just try to look contract from many angles, so that if we can find any error, that will be better before going to production. So this is how actually we we try to have a better security layer over our all the products.
Yeah, I see. I see. Actually, is it all that like we can do? I think trying to audit as detailed as possible, and do not update anything after audited already, or need to re-audit if we update the contract. So okay, we are seeing the sandbox is really a great tool. So are you consider it as a playground or testing purpose, or is it will be like a development tool? I just asked because I'm a Solidity developer. So let's say if I want to move to this, can I just keep our current development tool sets and the environment config to easier to involve into it?
So like you mean like you want to create cross-chain DApps using crosstalk library. So the question is how we go about doing it, like what environments to set up and all, right? Is that what you asked me?
That's right. That's right. That's right.
Okay. So like as I said, like you just need to import. Like, I'm talking about crosstalk library in general. So you just need to have some imports of the library, like the interfaces and all, the in which like functions are defined, like functions are there which you can implement in your smart contracts, and you just need to deploy those contracts to the blockchain. Like let's say source blockchain, you deploy that contract which are having the import like of that lab of crosstalk library, the source chain, and on destination chain. So this is what you need to do, and for doing this, uh, like the only thing that you need to do is like if you can also do it on Remix IDE, like by just going there
Mm-hmm.
and like having the imports there and actually deploying it in the source chain on the destination chain, as well as like since for even compatible development, we also use some environment like Hardhat and all. Like you can also use that as well. So like it's very similar to doing. It's very similar to deploying a normal smart contracts. You just need to have some of the imports. That's all. So nothing extra you need to do, just some imports
Okay.
and deploy in the same way you do for the normal smart contracts on even compatible chains.
Okay, I see. So just need to import the router protocol libraries into our contract and just adding some code without anything need to do extra under the hood, right?
Exactly. So like
Okay.
you like for example, there's an NFT contract, cross-chain NFT contract. So like we have some of the functions of the gateway contract which you need to have in your contract. And let's say there is a function called isend function, which is used to send the data from the source chain to the destination chain. So in that isend function, like you need to call it, like you need to have that function in your smart contracts. Like then you will be deploying it in the blockchain, and then for sending the data, you need to call that function isend.
Okay, I see.
And then
I
on the
see.
destination chain, similarly, like you need to deploy it. And there is another function called iReceive, which will be automatically called by the gateway contract on the destination chain. And like we need to write the operations which we want to perform when the data gets sent to the destination chain. So the deployment process is like kind of very similar to do for it's very similar of doing it for the normal EVM based smart contracts. Nothing much. Except for the omni-chain thing, like for the middleware contract, obviously, like you need to write the contract in Rust because of wasm framework and then deploy it on the router chain. So that is for the omni-chain framework. But crosstalk framework, crosstalk library, nothing needs to be done extra. Like you can directly do it on Remix ID and Hardhead platform and all. Like nothing extra.
Okay, I see.
No involvement need to be set up.
Okay, got it. Thank you. And another questions from the communities that quite interesting. That's we are having the cross chain NFT, right, for EVM. But we also have some like other platform that have the NFT token like a Solana, and you know the audience asks because Solana NFT is quite different between the EVM NFT. So do you have any plan to create your template for NFT in Solana to make it like can be crossed with the EVM one?
So right now we have support for EVM chains as well as for the near chain as well. And like this is a future prospect. We'll also be working on the Solana part. And our vision is to basically integrate all the chains that are in the world, not just Solana, but any chain if it exists in the world. So it should be integrated with the router protocol so that we can create cross-chain apps. But right now we are just have support for EVM chains and near. But in future, obviously, we'll be going for Solana as well as other blockchains.
I see. For now, it's EVM and near, right? Okay, I see. Okay, and I think that is good enough. Maybe I need to like leave the stage to Nicole to take it from there. Thanks everyone for the questions, and thanks guys for the answers. Thank you.
Okay, thank you so much, Pranav, Shashvat, and Saloni for making time. So we have close to 50 people joining us today. And there are also like a lot of pending questions as well, but due to time constraint, we won't be able to put all of these questions in the program. So for any of the remaining questions, so our team here, Alex, would you mind maybe save those questions so we can share with Router Protocol team later. So we're going to have a recap blog as well on ABC Station channel and our partners channel so that you can also review this, also capture some of the highlights of today's session, and of course to mingle with Router Protocol. So basically, we are also working with partners to have the AMAs for education as well as having some follow-up office hours if there's any follow-up interest in terms of building on Router Protocol and on our partners platforms. So we hope that we can see you and, on our Discord channel later, for all of those follow-up sessions. So again, guys, thank you so much for making the time. I know it might be a bit late for you guys here in Vietnam and also maybe past over like dinner time in India already. So thank you very much for, for making the time. I think the community really love this. And we look forward to, of course, having more follow-up sessions with you. So have a great night, everyone. We'll have more follow-up sessions soon. So thanks again, and do follow ABC Station Discord channel and social media.
So thank you guys for this session. And we'll be continuing it some other day with some more questions, some better questions. And I will definitely love to take all the questions from you guys at that time. So for now, bye-bye. Have a great day. And see ya.
See you guys.
Thanks for having us
See ya.
here.
Thank you guys.
See
Thanks for
you.
coming.
Bye. Bye-bye. Thanks everyone for joining in, for tuning in today. Do follow our channels so we can keep you updated by the next sessions very soon. We're going to have more interesting sessions with XLR Foundation and Fund Foundation this month. And again, thanks Mike and Sotatech team, Metatech team, Wayback DAO team for being here and supporting the program. Have a
Yo,
great night, everyone. Yes.
good
See you
night.
soon.
See you.
Night night. Bye.